what happens when you want to find the area between two curves? For example, here we have a blue curve f of x and a green curve g of x. And let's say that I want to find the area between these curves from A to B. So that's this area in here. Well, it's very easy. First of all, if we found the area underneath f of x, or the integral of f of x from A to B, we would be finding this entire area in here, all of this blue stuff. But we don't want everything from the x-axis to g of x. We want to be able to subtract out this area underneath g of x. Luckily, all we have to do is take the integral of f of x to get the entire area beneath f of x, and then subtract out the integral of g of x. And what that will do is that will just remove this area from g of x down to the x-axis. So, to put it formally, the area between f of x and g of x is, we take our greatest function, the one that's above the other one, and we take the integral from a to b of our upper function, which is f of x, minus our lower function, because that would give us, remove all of this area down here, so minus g of x, and that's dx. And this is the formula for the area between two functions. The integral of your upper function minus your lower function. Now, what happens if your lower function is below the x-axis? Wouldn't this change anything? The answer is no. Actually, it doesn't change anything at all. Because if you found the integral of f of x, that would be finding this area in here. But then you'll be saying, hey, but wait a minute, isn't the integral of g of x going to be negative? Well, yes, the integral of g of x is negative, but remember, if we took the integral of f of x, which gives us this blue area right here, and then we subtracted off the integral of g of x, which is a negative area in here, remember that our blue area minus our green area, well, that's the same thing as adding our two areas together. So, our formula is the exact same. We have the integral from a to b of our upper function minus our lower function. Because when you subtract off the integral of g of x, we are subtracting off a negative area, and minus a negative area is plus. So that means that we are adding these two areas together. The fact is that our formula still works. Now there's one more case to look at, which is what happens if my two functions were to cross somewhere in between a and b. Well, let's take a look. We want to go from a to b, and so we're looking at this area in here. The problem, though, is that our formula is our higher function minus our lower function. However, at this point right here, g becomes my higher function. Well, let's call this point c. We can take the integral from a to c. Let's make this a little bit smaller. We can take the integral from a to c. Our higher function is f of x, minus our lower function is g of x. And then we can add on the integral from c to b. Our higher function is g of x, and our lower function is f of x dx. So, if ever your functions change, where your upper function becomes your lower function in between your interval, all you have to do is break it up where those two functions intersect. We'll call that c. And you can take the integral from a to c of your upper one minus your lower one, and then add on the integral from c to b of your new upper function minus your new lower function.